Did you know that you can never measure the voltage across a component? I know that sounds weird because we've got voltmeters. What are they made to do? Well, they're made to measure the voltage across a component. But did you know that when you connect a voltmeter to the device, you've actually changed the circuit because before it didn't have a voltmeter and now it does? So big question is, how much does that matter? Does it really matter when we connect a voltmeter into the circuit? And if so, do we have to be careful about how we connect it and how we take our measurements? Well, the answer isn't as straightforward as simply yes. Most of the time, our digital multimeters, especially in a context of industrial or control engineering, the devices and the meter are so different in resistance that it doesn't really make any difference. So as long as you're using a good digital multimeter, you probably never have to worry about this. But it is very interesting. So let's compare this digital voltmeter and an analog voltmeter to see what the difference is in the loading. So first, let's test this 24 volt circuit to make sure that we do have 24 volts as a source. And sure enough, we do. And then I've placed two 100 kilo ohm resistors in series with each other. Now 100 k ohms is a fairly large resistor, but it's still quite a bit smaller than the internal resistance of the meter. So let's measure across each one and let's see what the voltage is. For our first resistor, we measure 12 volts. And our other one, just under 12 volts, but that checks out. These are both 5% resistors, and so they have a little bit of variation, but sure enough, 12 volts plus 12 volts makes the 24 volts. And if it was off by a couple of hundredths of a volt between testing and not testing, that's not gonna make a difference for our test. So let's turn to the analog voltmeter and see what the difference is. Now in an analog voltmeter, we usually have different ranges here. So I'm going to change this to the 150 DC volt range just to verify that I do indeed see 24 volts at the source to make sure that the voltmeter is working. And as we can see, on the 150 volt range, each of the large tick marks is 50 volts, and I'm almost exactly halfway between the first and second tick mark, which means half of 50, which is right about the 24 that we're looking for. Now the problem with analog voltmeters is we might not be able to measure down to the hundredths of volts scale, but sure enough, I do see the 24 volts coming from the supply. So I'm going to adjust down to the 15 volt range and see if I get the 12 volts that I expect across the terminals. So I connect the first resistor, and when I'm on the 15 volt scale, each one of the tick marks is 5 volts. I'm only up to the first tick mark. That means I'm only measuring about 5 volts. That's interesting. Let me switch over to the other resistor and see if it's dropping the rest of the 24 volts. No, here again, I'm dropping less than 5 volts. So 5 volts plus 5 volts only makes 10 volts. How is that coming from the 24 volt supply when all I've got are two resistors? Well, down in the bottom corner, I see 2 kilo ohms per volt. When I'm on the 15 volt range, that means that that's only 30 kilo ohms of internal resistance. The meter is far less resistance than the resistors in the circuit, and therefore most of the voltage is actually being dropped on the meter, not the original circuit. So as soon as I remove the meter, they're dropping 12 volts equally, but I can never actually measure that with the meter due to the loading effect of the meter in the circuit. So again, most of the time, if you use a digital voltmeter and the load resistors are much lower than the resistance of the meter, you're fine, you never have to worry about this. But if you're testing a high resistance circuit, like a digital circuit with integrated circuit chips or transistors, and you try to use an analog voltmeter, you're probably going to be in for a big surprise. So that's why digital voltmeters are very often the go-to device with that extremely high internal resistance for more accurate voltage measurements.